Okay, we're going to go over number 4 from the quiz today. Given the diagram below is point P on the perpendicular bisector of AB. Explain how you know. Okay, so in order to answer this question, you need to remember that every point on a perpendicular bisector is equidistant, the same distance from each of the endpoints of the segment it's bisecting. In other words, if P is truly on the perpendicular bisector of AB, then P is the same distance to A as it is to B. Okay, so you've done problems like this before, finding the distance from P to B and from P to A. And we've always used the Pythagorean theorem in making little right triangles. So let's first find this distance, PA. So I'm going to make a little right triangle with one of the legs is 2 and the other is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I'm looking for what is this distance, PA. So over here, I know that PA is the hypotenuse. So that squared is equal to 2 squared plus 8 squared. Or PA squared is equal to 4 plus 64. Or PA squared is equal to 68. But I want to know what PA is, and right now I only know what its value is squared. So if I take the square root of both sides, PA equals the square root of 68. I don't really need to worry about simplifying this because I'm just curious, is PB also the square root of 68? And if it is, then P is in fact on the perpendicular bisector of AB. Okay, so let's test it out. Let's make another right triangle, but where PB is the hypotenuse. So one of its legs will be side length 1, 2, 3, 4, 5, where the other is 1, 2, 3, 4, 5, 6. Okay, so now I want to know what side length PB is. So using the Pythagorean theorem, I have PB squared equals 5 squared plus 6 squared. Or PB squared equals 25 plus 36. So PB squared equals 61. Okay, so now to just solve for PB, take the square root of both sides, and PB is equal to the square root of 61. Okay, the square root of 68 is not equivalent to the square root of 61. Therefore, PA does not equal PB. So P is not on the perpendicular bisector of segment AB.